ladies and gentlemen, please clap, cheer, stamp your feet, Dr. Ben Littlefield.
Good evening, ladies and gentlemen. Because I am indeed the warm-up for tonight, I have the delight of being able to choose my own topic. I'm also immune to the trepidation of awaiting your judgment at the end. I can laugh at the rest of them. And I get to give an extra 8 minutes of well-rehearsed anxiety to the science slammers waiting in the wings. Good luck. This evening, I'll be talking to you about a muse, a bringer of life, and an illuminator of dim, untrodden paths, both literally and metaphorically. I am talking about light. Now, it has been said that light, the first phenomenon of the world, actually reveals to us our spirit and living soul through colour. And indeed, the kaleidoscope of colours around us inspires the arts, describes our emotions, and even applies order onto our daily journey. Now, it's perhaps quite surprising then that it wasn't until very recently that we truly understood that colour was a quality of light. Up until recently, we believed the view of the ancient Greeks, that light was a heavenly solar force which was adulterated by its interactions with the base matter on the Earth. Sir Isaac Newton and his famous experiments with prisms showed us that actually white light is made out of colour. And different colours arise from absorption, transmittance, and indeed reflection. Now I'm going to try something very dangerous. I'm going to try some audience participation, so I'm going to need the house lights up, please, for this. Underneath your chairs, there are stuck glow sticks. I would like you to get them out and hopefully not touch anything unpleasant. So it's right under your seats. Now we have got a time limit, so please be quick about this. Please snap the glow sticks and give them a little shake to initiate them. All right. That's looking fantastic. Right. The more observant of you would have noticed that you are actually arranged into blocks of colour. Red is right on your right-hand side, and that's the longest wavelength light. And right on your left-hand side, the shortest wavelength light is violet. Now, I've mentioned the word wavelength. That is because light is both a wave and a particle. And that means it has both wavelength and frequency. And what I'm going to do is I'm going to get you to demonstrate this. Now, hopefully you've all been exercising recently because this does require some upper body strength. Everyone holding a red glow stick, would you please raise it in the air and then very slowly lift it up and down. Very slowly, please. Orange, a little bit faster, same thing. A little bit faster though. Yellow, faster still. Good, we're getting the hang of this. Green, quite fast now, please. Blue, really fast. Indigo, really, really fast. And violet's as fast as you possibly can. And fantastic, and stop. Well done. That was actually worked really well. I'm surprised. You were the visible spectrum then, and showing the difference between low frequency, long wavelength light and high frequency, short wavelength light. Now that brings us to the excellent question of where does light actually come from? Now we're all familiar with that baleful orb in the sky, the sun, which produces light for the Earth. But there are other forms of light, thermal emissions like fire and incandescent light bulbs. There's also cold forms of light, biological sources like glowworms, or chemical reactions giving rise to something called chemiluminescence. If you go home later on today, you can even crush a sugar cube, and that will produce light called triboluminescence. Now, what I want to show you, though, today is something quite special. What I have here is a chemiluminescent reaction, and safety is very important, so safety glasses go on. Inside this measuring cylinder are two chemicals. One's called luminol, the other one hydrogen peroxide. And in front of your very eyes, they have been reacting really slowly and really boringly. If we take the lights down and I add a third chemical, something quite magical happens. Right the way down, please. Watching very carefully. That's quite cool, isn't it? So what I'm doing is I'm adding a chemical which speeds up that chemical reaction. It's called a catalyst, lowers the amount of energy required, and gives rise to chemiluminescence, which is very similar, exactly, sir, to what's going on with our glow sticks. Can we have the lights back up, please? Okay, so we're now familiar with the fact that light is made out of colour and the different sources of light, including the sun and chemiluminescence. However, this is where it gets really interesting. Visible light, what you all were a minute ago, is just a tiny sliver of the electromagnetic spectrum. It wasn't until the 1800s when William Herschel made a fantastic discovery to be realised there was something more. William Herschel was looking at the temperature of colours using a prism, and he discovered that the highest temperature was beyond red. William Herschel had discovered infrared radiation. Now, this ushered in a whole new range of electromagnetic radiation, including ones you should be familiar with, ranging from, going completely blank for a second there, radio waves, to microwaves, to ultraviolet, to X-rays, and even gamma rays. And what makes this so special is we can use those different types of radiation to investigate matter in the world around us. We can actually identify the structure of materials. And if we know the structure, we can figure out its properties and its applications. So it really does underpin a lot of scientific research. Now, let's give you an example. For instance, ultraviolet lights, the bane of the sun worshipper. Ultraviolet lights can interact with molecules to cause them to fluoresce. If we can have the lights down again, please. I have in my hand right now an ultraviolet laser, and if I shine it through a highly exciting tank of water, you can see sort of a laser beam in there. It's not the most exciting thing in the world, is it? But what happens if I shine it through a tank filled with tonic water? Let's move this out of the way. Something a little bit different. Inside the tonic water is a molecule called quinine, and that absorbs ultraviolet light and re-emits it as a visible light. If we can have the lights back up again, please. Now, from that fluorescence, which is what that's called, we can determine the concentration of quinine and even its environment as well, and so we get some valuable information about it. There is another type of radiation we use a lot, though, and you should all be familiar with it. X-rays. You're familiar with it in a medical context. Probably people have had X-rays with bones that are broken and that sort of thing. But did you know we can use X-rays to actually probe the internal structure of things like crystals? We can shine an X-ray at a crystal and it will interact with the repeating arrangement of atoms within this crystal and be split, be diffracted. Now, unfortunately, I wasn't allowed to bring an X-ray source in this evening, something about health and safety. I don't know. So instead, I have an alternative we can use. I have here a visible light laser, which, if the house lights could go down again, please, I will shine on the ceiling. And you should be able to see a very sharp, impressive green dot and possibly a laser beam going up to it, right behind you at the back. I'll do it up here so more people can see it. Now, our laser represents the X-rays, and this grating here represents our crystals. If I put the grating over the laser, you see it splits. And different crystals, different structures, give rise to different patterns. Now, what's really special is we can work out the structure of our materials from these patterns. And like I said, if we know the structure, we can work out the applications. So, light is not just the bringer of life and something we take for granted every day. It's actually fundamental to how we understand the universe around us. Hopefully, you found that illuminating, and I hope you enjoy the rest of the Science Slam. Thank you very much.